Okay, so number 22, let's look at keywords. Let's try to now become more efficient. Not missing steps, but just trying to recognize them quickly. We're going to revolve the region bounded about the x-axis. So already I'm envisioning whatever it is, it's going to revolve vertically so that I have what kind of slices? Vertically. dx. Okay? So these are vertical slices, and each of them are going to be either a disk or a washer if there's void, but we know that it's going to be dx. Are we good? Okay. So let's go ahead and draw, let's draw what this would look like as far on a graph. So the reason why on this particular problem, if it was on a CFA, or if it was on a test, or on the AP exam, which I don't think it would be, this is just, they usually do these as non-calculators, is because we don't know like that what the arctangent of that would look like. Okay? So let's go ahead and put that into our calculator real quick. Can someone help me out on that? Put that into the calculator. I'll pause the video. We'll come back whenever you have what it looks like. Okay, so arctangent also looks like this. Otherwise, some people call it inverse tangent. So putting that into our calculator, we have something that looks like this. So let's do this graph in blue. We have that. Okay? And now what we're going to do is we're going to put y is equal to 0, which is not a vertical, but a horizontal line. Go with me? We're now going to do, let's do this in purple, x is equal to 0, which is just which axis? Y-axis. And then last but not least, we're going to do, I'll do it in another purple, x is equal to 3. Which please don't make these fundamental mistakes. X equals something is a vertical line. Y equals something is a horizontal line. So from all of this, we have this shaded region right here that's bounded between everything. And step 1 is done. Find the region. That's step 1. We know they are vertical slices, so they're going to rotate about the x-axis like that. Okay, out of the page, around. You with me? Here comes the second question. Second step. Is it washer method or disk method? Disk. All right, so there's my area. We're revolving it about the x-axis. And you guys said it before I paused the video. It is going to be washer or disk method? Disk, because there's no void, right? There's no void. There's no empty space between the most bottom function, which they gave us, was y is equal to 0, and the axis of revolution itself. It basically kisses the axis of revolution everywhere throughout that interval. So it's disk. Sorry for the analogy, but you'll remember it. Okay, so as I'm rotating this, you have a bunch of disk methods, right? So if I rotate this, just to see where you're at with understanding, what would this look like if you rotated it? What
do you mean? Oh, like a semi-sphere?
It looks like a semisphere, right? Sorry, a hemisphere. A hemisphere. So it looks like half of a sphere, if you will. Or it looks like something like a bowl of some sort, but when you actually rotate it, it's solid. Like there's no emptiness on this. It's solid. You with me? Okay, so let's keep going. Because it's disk method, thank you for asking this, Madison, because we haven't done a disk method yet. Because this is disk method, what is the equation for disk method?
Just big radius.
Just big radius. Just one radius, right? It's just pi r squared, and that's it. So it's going to be pi, r squared. Here's r squared. And we know they're dx slices because they're vertical slices. Okay, let's be very, very methodical with our next steps. We have a big R. And inside R, we're going to determine, Brooks, we're going determine r how? How do we determine the length of the radius?
By taking the top function
And then minus
minus the bottom function,
the bottom function.
which in this case would just be 0.
So look, let's be methodical, because he said in this case. If you develop that in this case, that's good. But otherwise, be very methodical every single time. And I'm going to draw a radius right now. And if you've been listening, you'll know where, starting from where. Where am I going to draw this radius from? Starting from where?
X-axis.
The axis of revolution, which in this case is the x-axis. So from the axis of revolution going to the outermost function, that's when I know when to stop. But my point is, I drew it intentionally from the axis of revolution to the outermost function. And the reason why I do that is because sometimes we will have to go down to get to the outermost function. But if you always start from the axis of revolution, you'll do it correctly as far as how you set up your big R versus your little r. Go ahead. What's your question?
Why wouldn't you do the
We're not doing this yet. We're not determining the functions yet. All we're determining is visually, I know that I will have a big radius that starts from the axis of revolution and goes to the outermost function. And that right there that I just drew is my big radius. Now I'm ready to say, what's the top function minus the bottom function? So the top function, what's the color, guys? Blue. This is the top function. And the top function in blue is going to be 3 arctangent of 0.4x. And I'm going to subtract the bottom function, which is what? 0. Would I want you to write that on the test, do you think? Yeah. Because I don't want you to miss it for all the other ones. Okay? So we have our big R minus the little r. There's no void. That's why we don't have another r squared. Now I just have to say it's from what to what bound? From 0 to 3. If I put this into my calculator, just make sure you're reading directions if it's a CFA for those 4 decimals when applicable, or whatever it is that you're supposed to round to. Questions? All right. Are there